Hello and welcome to Controllerstech. This is the sixth video in the STM32 UART series, and today we will communicate using a single wire, the half-duplex mode. We have already covered how to send and receive data via the UART using different methods. One thing which was common in all the previous videos was that we were using the full duplex mode. That means there were two wires for the communication, one for transmitting, and another one for receiving. Single wire mode is used to transmit and receive data only using one wire, but at a time. At one particular time, the MCU can be either a sender, or a receiver, it can't be both, and that is why this is called a half-duplex mode. Let me give a quick overview of what is going to be achieved in this video. I am going to transfer data between two MCUs. They both are not going to be Nucleo boards, this picture is just for demonstration. Since we only have the TX pin available in the half-duplex mode, they will be connected to each other. Initially both the MCUs will be in the receiver mode. When the button on one of them is pressed, that MCU will become the transmitter. It will send some data via the TX pin, and the receiver will receive that data. We will see the data in the live expression. Once the data transmission is complete, the sender MCU will again go in the receiver mode. When the button is pressed on the second MCU, it will become the transmitter, and transmit the data via the TX pin. The receiver will receive this data, and we will again see this on the live expression. After transmission, it will also go in the receiver mode. Let's start the CubeIDE, and create a new project. I am using STM32 F446RE. Give the name to the project, and click Finish. Let's set up the clock first. I am going to bypass the external crystal, so that it can use the one from the SD link on the board. The crystal is 8 MHz, and we will run the system at maximum 180 MHz. Let's set up the UART now. We can't use the UART 2, as it is connected to the SD link in the Nucleo boards. Let's use the UART 1 instead. Enable the single wire half-duplex mode. Here you can see the pin PA9 is configured as the TX pin, and this is the only pin we have. We will leave the configuration to default, but make sure the same configuration is used on the other MCU as well. Now go to the GPIO setting, click on the pin PA9, and enable the pull-up for it. This is necessary to receive the data. Some MCUs like STM32 F103C8 do not have the option for the pull-up here, so you need to connect one external pull-up resistor to the line. Now go to the NVIC tab, and enable the UART global interrupt. We will use the interrupt to receive the data. The user button on this Nucleo board is connected to the pin PC13, so configure the pins as the external interrupt pin. Now go to the GPIO tab to configure this pin. Let's enable the pull-up for this pin, so when we press it, it will be pulled low to the ground. The interrupt will trigger for the rising edge, that is, when the button is released. Go to the NVIC tab, and enable the interrupt for the XD pin. That is all the configuration we need. Click Save to generate the project. Let's build it once. Alright, here in the UART 1 initialization, you can see that the UART is initialized in the half-duplex mode. We only have 3 functions for half-duplex mode. One is to enable the transmitter, next to enable the receiver, and third one is the initialization. As I mentioned in the beginning, the MCU will always be in the receiver mode, unless the button is pressed. So let's enable the half-duplex receiver mode. Now we can use any method to receive the data. I will use the receive to idle in the interrupt mode to receive 30 bytes of data. Once all 30 bytes have been received, or an idle line is detected before that, an interrupt will trigger and the RX event callback will be called. Here we will again call the same function, so as to maintain the continuity in the reception. You can simply leave it to HWART, or use the HWART1. Let's define the RX data buffer to store 30 data bytes. The index variable will be used in the transmitting. TX data will store the data to be sent. The isClicked variable will track if the button is pressed or not. Now we will handle the GPIO external interrupt. When the button is pressed, the XD callback is called. Inside this callback we will check if it is called by the pin number 13. If it is, then we will check the value of the isClicked variable. If the variable is 0, we will set it to 1, otherwise nothing will happen. Inside the while loop, we will again check the value of the isClicked variable. If the variable is 1, that means the button is pressed, and we need to send the data. We will prepare the data first. Basically we will copy this string, along with the value of the index variable to the TX data buffer. Each time the button is pressed, the index variable will increment, so that there will always be new data to send. Now that we have the data, let's put the UART in the transmitter mode. Then we will send the data to the UART. The sprintf function returns the total length of the string, so we will use it as the size parameter in the transmit function. Once the data has been transmitted, put the UART back in the receiver mode. Also reset the isClicked variable, so that this loop doesn't run again. Let's build the code now. We need to include the standard I/O header file for the sprintf to work. Let's also add a small delay here, so that we don't get the key debounce. Let's build and debug the project now. Here I have added the RX data, and the index variable in the live expression. I have the STM32 F411 discovery board as the second MCU. Here you can see the pin PC6 is enabled as the UART6TX pin. The rest of the configuration is the same as what we have seen for the Nucleo board. You can see here, it is exactly the same code as what we wrote for the Nucleo board. Let's build and debug it. This board is connected to another computer, so we will see the live debugger for both the boards simultaneously. The UART1TX pin PA9 from the Nucleo board connects to the UART6TX pin PC6 on the discovery board. You can see both the debuggers now. Let's click the button on the discovery board. I am pressing the button, but there is no data received on the Nucleo board. You can see the index variable is 2, which indicates that the data was indeed sent, but it was not received. The same happens when I press the button on the Nucleo board. This is happening due to different power sources. We should at least have a common ground between both the boards. So I am connecting the ground between both the boards. Let's try sending the data again. Now you can see the data has been received by the Nucleo board. The value of the index variable is 3, and the same data has been received by the Nucleo board. Let's press the button on the Nucleo board now. The index variable on the Nucleo board is 2, and the same data has been received by the discovery board. Keep an eye on the value of the index variable, and the data received by the Nucleo board. Let's keep pressing the button on the discovery board. The data is being received by the Nucleo board, and the value is the same as the index variable on the discovery board. So the communication is working fine both ways. We are able to use one wire to transmit and receive data between two STM32 boards. This is it for this video. I hope you understood the communication using half-duplex mode. You can download the code from the link in the description. Leave comments in case of any doubt. Keep watching, and have a nice day ahead.